Assalamualaikum warahmatullahi wabarakatuh, and good day to all. My name is Azman bin Talib. For introduction, we are living in the world of increasing with population and energy consumption every day. So there is some limitation of fossil fuel usage, but also create environmental issue like ozone depletion, greenhouse effect, pollution, and etc. So there is a need to change to alternative renewable energy like wind, solar, tide, biomass, hydro, wave, or geothermal. For this study, we are focusing on the solar renewable energy. Why we choose solar? Because it has abundance of availability, high potential, ready available, renewable and sustainable, and also supply kind of clean energy. So there is a few generation of solar cells which have been made. First generation of solar cells is made from wafer-based solar cells like monocrystalline, polycrystalline, and gallium arsenide. And the second generation of solar cell is made from thin film solar cells like amorphous silicon, copper indium gallium selenide, and cadmium telluride. And now is the third generation of solar cells. For example, organic, dye-synthesized solar cells, quantum dots, and also perovskite. And for the study, we are focusing on the dye-synthesized solar cells. This RGO volume incorporate into anatase titanium dioxide nanoparticle overlayer onto rutile titanium dioxide nanostructure. So in this experiment, we mix the RGO solution with the anatase titanium dioxide solution as a nanocomposite mixture. Then the solution will be sprayed onto the sample consists of nanorod and nanoflower. So first we will prepare the synthesis of the rutile titanium dioxide nanostructure by hydrothermal synthesis, and then we prepare the RGO via impure Hammer method, and we prepared also the solution of anatase titanium dioxide. And for this experiment, first 10 ml of anatase titanium dioxide nanoparticle is poured into four different beakers. Then 1 ml of RGO was added into the first beaker. Then 2 ml of RGO volume added to the second beaker of anatase titanium dioxide. Then 3 ml of RGO added to the third beaker, and 4 ml of RGO lastly added to the fourth beaker. So there is a different volume of RGO added into 10 ml of anatase of titanium dioxide. And then from each beaker, we will take 2 ml from each beaker to do the SPD deposition onto the sample of rutile titanium dioxide. So 2 ml from each beaker will be sprayed onto the sample of rutile titanium dioxide, and we denote as first sample as RT1, second sample as RT2, third sample as RT3, fourth sample as RT4, and as for the reference, we will spread only the anatase titanium dioxide onto the rutile titanium dioxide. For SRD result, because the titanium dioxide P25 powder also contains 35% of rutile, so rutile peak also have been found, although the composite mixture solution is fully covered onto the rutile face of the outer surface. And for the electrical properties from solar simulator, it shows the highest efficiency for sample with 4 milliliter of nanocomposite sprayed onto the rotile face of titanium with a 5.72% of efficiency. So we can conclude that the structure of the RGO anatase phase of TiO2 and rutile phase of TiO2 on the FTO substrate process significantly contribute improvement to help lower the band gap and increase photon harvesting, thus resulting in good photocurrent activity. And as the result, the SAC cell using the RGO composition at photoanode exhibits greatly improved photovoltaic performance as compared to the normal rutile phase of TiO2 nanostructure without any RGO addition. For the SAC fabricated using 4 ml of RGO volume with 2 ml sprayed on rutile phase of TiO2 exhibit the best photovoltaic performance with the highest conversion of 5.72% and most excellent current density of 10.37 milliamp per centimeter square. And this experiment demonstrates the introduction of geo incorporation into TiO2 work as one of a successful method for the photovoltaic performance of the SAC improvement. Thank you.